Hello. So today's lecture is going to be over what you learned in the previous class on Tuesday with Mrs. Brown. This is going to be additional practice working with those exponential equations. So there's no new material today, just some extra practice. So in this video, I'm going to go ahead and review some of the concepts you learned on Tuesday with some examples, and then we'll pause the video and let you work on a quiz throughout the video. So we're going to go and start with this, what I call part one, which is solving exponential equations where one constant is a power of the exponential. What I mean by that, 36 is a power of 6. Notice 9 is a power of 3. Here, if you isolate the exponential, you'll get a power of 4. And that is always a good pointer when you're solving these exponential equations. It's a general rule of thumb. You always want to isolate the exponential first. So always do this first. So suppose I want to go ahead and look at this first example. I can rewrite 36 as 6 squared. Since exponentials functions are one-to-one, x has to equal 2. In other words, 6 to what power equals 6 raised to the second? If you ask the question, you'll know the answer. The answer is 2. You probably could have guessed that just by looking at the equation. Now this one's a little bit more complex. I can rewrite 9 as 3 squared. Just like that. And note, they're the same base, but you have to apply your properties of exponents. So if you recall, if I have an exponent raised to an exponent, you multiply the powers. So when I multiply them, it's going to be 2 times 2x plus 1. So 2 times 2x is 4x. 2 times 1 is 2. So remember, when you have an exponent raised to an exponent, you multiply the powers. So you multiply those, you get that. And it's the same thing. 3 raised to the x minus 1 equals 3 raised to the 4x plus 2. That can only be true if those two powers are equivalent. So you just want to go ahead and solve that equation. So subtract x from both sides. Right, and then I'll go and subtract 2 from both sides. And then divide accordingly. So therefore x equals negative 1. There's my solution there. All right. So let's go ahead and take a look at this next equation. As I mentioned earlier, you want to isolate the exponential first. So we're going to go ahead and add 3 to both sides. Note, when I do that, I will get 16. You notice from going plus 3 to both sides. And I can rewrite 16 as 4 squared, therefore x equals 2. Right, because 4 squared will equal 4 squared. So that's what you can do if the constant is a power of the exponential you're trying to solve. So go ahead and please pause the video now. I want you to go and pause the video and attempt those 3 questions on your quiz. Those part 1 questions will be very similar to these examples. So go ahead and pause the video and continue playing it when you're ready. Alright, at this point in time you should have been done with those part 1 problems. Again, you should be done with those. We're going to go ahead and look at part 2. So part 2 is how do I solve it if the number is not a power of the base. So note 19 is no power of 5. You got 5 squared is 25, 5 to the third is 125. 19 is not a power of 5. So what we're going to need to do here, we rewrite the equation real quick, is we're going to go ahead and log both sides. Now you can use any logarithm you want. I'm very fond of using the natural logarithm. So I'm going to natural log the left and natural log the right. Because what I do to one side, I have to do to the other side. Now note, properties of logarithm state you can take this exponent and pull it out front as a coefficient. So that means x times natural log of 5 equals natural log of 19. And then to get x by itself, all I have to do is divide. There you have it. There's our answer. So x equals natural log of 19 over natural log of 5. And if you want, you can write that as a decimal. So I could take my calculator here, and I can hit natural log of 19 divided by natural log of 5 is that number. So if I take it to 2 decimal places, that's roughly 1.83. Now let's look at that answer. Does that sound about right? We're trying to figure out 5 raised to what exponent equals 19. Well, 5 raised to the first power equals 5, which is too small. 5 squared is 25, which is too big. So I know this answer has to be somewhere in between 1 and 2. And there you have it, 1.83. This next example is going to be very, very similar. The only big difference is you're going to have to isolate first. So subtract 2 from both sides. All right, once you've isolated it, now go ahead and log both sides. And I like to use the natural logarithm. So we're going to go ahead and natural log both sides, natural log the left, natural log the right, and I can pull the power out. Now when I pull that power out front, I have to treat it as a single expression. I have to keep it in parentheses, in other words. Like that. So when I take that power and I pull it out front, I have to keep it in parentheses. And then I'm going to have to distribute that irrational multiplier. So I get x times natural log of 3 minus 4 times natural log of 3 equals natural log of 5. So all I did there is distribute ln of 3 times x, ln of 3 times 4, so you can see there. I'm going to go ahead and add ln of 3 to both sides. I'm sorry, add 4 ln of 3. Now remember last week we talked about combining logarithms. So we can combine logarithms that are being added together. Remember when you're combining logarithms, you're going to go ahead and pack that power in. So that's ln of 3 to the 4th. And recall that when I when I add logarithms, that translates into a multiplicative property. So ln of 5 plus ln of 3 to the 4th can be combined to ln of 5 times 3 to the 4th. So let me see what 5 times 3 to the 4th equals, which is 405. And then you can go ahead and divide both sides by ln of 3. And there's our answer, x equals, remember that simplifies to 405. So natural log of 405 divided by natural log of 3. Kind of running out of room here. There you have it. Natural log of 405 divided by natural log of 3. Now I just want to pause here for a moment. A few key steps here. You log both sides. Bring that power down. Make sure you distribute. Very important. And then move that other logarithm over. And if you're adding logarithms, you can combine them. So adding or subtracting logarithms, they can be combined. But if you're dividing logarithms, no dice. That's as far as we can take it. So let's go ahead and do some more examples. So here, again, you want to isolate first, so I'll subtract 1 from both sides. And then I'll go ahead, once it's isolated, I'll go ahead and natural log both sides. That allows me to pull that power out front. Now this one's a little bit easier than the previous example because I don't have to distribute anything. So all I got to do is divide both sides by 7 natural log of 8, 7 natural log of 8. Right, because that cancels and the 7 cancels that. And I can write that as natural log of 24 over 7 natural log of 8. There's my answer. And remember, I can't combine logarithms over division. I can only combine them over addition or subtraction. Look at number 4. We're going to go ahead and subtract 1 from both sides to isolate the logarithm. Isolate the exponential. And then we're going to go ahead and log both sides. Natural logarithm left, natural logarithm the right. And then go ahead and pull the power out front. So remember, properties of logarithms allow us to pull that exponent in front, and then just simply divide and we're done. So divide both sides by negative natural log of 4. Notice that'll cancel the negative there. So x equals natural log of 9 divided by negative natural log of 4. There we have it. Alright, at this point, go ahead and pause the video, and I want you to work through the Part 2 problems. Feel free to help each other. You're allowed to work together. You can rewind this video if you want to watch one of the previous examples if you so desire. But don't move on to Part 3 of the video until you have finished Part 2 of the quiz. Alright, I'm assuming you finished Part 2 of the quiz. We're now going to move on to the final part, Part 3, which is working with natural exponentials. Our strategy actually remains the same. You still isolate it. And note here, there's nothing to isolate. You still natural log both sides. Like that. So you still take that exponent, pull it in front as a coefficient. But what makes these different is that natural log of e, those are inverse functions, they just cancel out. In other words, it just equals 1. Natural log of e equals 1. Because you're asking e raised to what power equals e raised to the first, the answer is 1. And you can even see that in your calculator, right? If I take natural log of e to the first power, so you can see there on the calculator, natural log of e, that just equals 1. So just note, whenever you see natural log of e, it just equals 1. So here on this problem, I want to go ahead and isolate first. So I'll go ahead and subtract 3 from both sides, bring everything down. Note, my exponential is not isolated yet. I'm going to divide both sides by negative 2 to completely isolate it. So I have e to the x equals 6. Now I'll go ahead and log both sides. Natural log the left, natural log the right. And then remember, I could pull the power out front. Now remember, natural log of e just equals 1. So when I have x times natural log of e, that's the same thing as x times 1, which is just x. And we're done. So if you're using natural logarithms, it makes it a lot easier to solve natural exponentials. Alright, I want you to go ahead and now finish the quiz. Once you're done with the quiz, you'll go ahead and turn it in. I will collect the quizzes and I'll get them graded for you on Friday. But other than that, have a wonderful day, and I look forward to seeing you all in the future.